Hello friends, welcome to Learner's Planet. Friends, in this session we are going to discuss basics of arithmetic, geometric and harmonic progressions, and I'll be solving some doubts sent by the students. So let's begin this session. Just be ready with your paper and pen, and let's begin. Now first of all, let's understand what is a progression. A progression is a sequence whose terms follow a certain pattern. That is, the terms are arranged under a definite rule. We can see over here 1, 3, 5, 7, 9. Now this is a progression of odd numbers, right? All the numbers in this series are odd numbers, right? And the difference between these two, and these two is same, right? So we can call it as a progression or a series. Okay. Now there are various types of progression: arithmetic progression, geometric, arithmetico-geometrico, harmonic, and some other, right? We'll be taking them one by one. First of all, we discuss arithmetic progression, that is AP. Now let's see the definition. A sequence of number Tn is said to be an arithmetic progression when the difference between nth term and n minus 1th term is a constant for all n belongs to n, that is natural numbers, right? This constant is called the common difference of the arithmetic progression, and we denote it by d. Here a is the first term and d is the common difference, and we can represent this AP as a plus d, a plus 2d, a plus 3d, and so on. We can take an example over here: 2, 7, 12, 17, 22. Here you can see the difference between these two is 5. Here also it is 5, here it is 5, and here it is 5, right? So throughout the series, the difference between the two consecutive terms is 5. So it is known to be an AP. Okay. Now here this is the first term, and this 5, that is the difference between two consecutive term, is known as common difference. Okay. Now you can see here the terms can be represented as a plus d, a plus 2d, a plus 3d, and so on. So nth term of this AP, that is nth term Tn, can be represented as a plus n minus 1 d, right? A. In the second term there is 1d. In the third term there are 2 d's. In the fourth term there are 3 d's. That means nth term n minus 1 d's, right? Fourth term 3 d's. So if I put n is equal to 4, I'll be getting 3 d's, right? So nth term of an AP is written as a plus n minus 1 d. If you put up the value of a, n, and d, you'll be able to get the get any number of any term of this particular AP, right? Suppose for this particular arithmetic progression, that is 2, 7, 12, 17, 22, if I have to find out say 20th term, so T20, what we can do is a is 2 plus n is 20, 20th term, that means n is 20, so n minus 1 will be 19 into d. D is what? 5, right? So 19 into 5 is 95 plus 2, 97. So that will be the 20th term of this AP. Okay, so if we keep on writing all the terms till 20th terms, it will be 97. Okay. Now we see sum of n terms of an AP. The sum of n terms of the series is given by Sn is equal to n by 2 2a plus n minus 1d, or n by 2 a plus l, where l is the last term. Here a is the first term, d is the common difference, and n is the number of terms, right? Suppose I take example maybe 1, 3, 5, 7, 9, and we have to find that sum of 10 terms, right? So here a is equal to 1, d is equal to 2, that is a common difference, and n is equal to 10, that is the number of terms, right? So sum till 10 term S10 will be equal to n by 2, that is 10 by 2, 2a, that is 2 into 1, plus n minus 1, 10 minus 1, 9 into D is 2. So it is 5 into 18 plus 2, 20. So it is 100, right? So sum of first 10 terms will be 100. Alternatively, we can use this formula also if we know the last term of the arithmetic progression. Then we can use this formula, that is n by 2 a plus l. Okay. Now how do we select the terms in an arithmetic progression? When the sum is given, the following way is adopted in selecting certain number of terms. Number of terms, suppose you have to select 3, then a minus d, a plus d. These 3 should be taken as the 3 terms of this particular AP, right? If you have to select 4 terms, so these 4 are the consecutive terms of an AP. Similarly, for 5 terms, we can choose these 5 terms as consecutive terms for the AP. Now let's see what is arithmetic mean. Now here, if the 3 terms A, capital A and B are in AP, then A is called arithmetic mean between A and B. I take an example over here. Suppose we have the 3 terms, say 1, 3, 5 and maybe more terms 7, 9. Then suppose we take these 3 terms, then 3 will be arithmetic mean between 1 and 5, right? That is, this plus this by 2 is this. Okay, this plus this by 2 is this. Okay, now suppose we take these 3 terms, then 5 will be arithmetic mean between 3 and 7, right? 3 plus 7 by 2 is 5. Similarly, we can take these 3, 5, 7 and 9. So 7 is the arithmetic mean between 5 and 9. 5 plus 9 by 2 is 7, right? So that's pretty simple. Similarly, if this is the sequence A, B are in AP, then A1, A2 are called an arithmetic means between A and B, right? So suppose 1 and 9 we are having, so 3, 5, 7, these are known to be arithmetic means between 1 and 9, right? Now how do we insert arithmetic mean? If A and B are 2 real numbers, then single arithmetic mean between A and B is A plus B by 2. But suppose we want to insert more arithmetic means, then what we do is, suppose we need to insert A1, A2, maybe n arithmetic means between A and B, right? So what we do is, A1 is the first, suppose this is A here and this is B here. Okay, so here it is A plus D, then A plus 2D, A plus 3D, and total, if n arithmetic means we have to insert, then total number of terms will be, these are n arithmetic means. So total number of terms in this AP will be n plus 1 plus 1. So total number of terms will be n plus 2, right? So here first term is A and n plus 2 term will be B, right? First term is A and n plus 2th term will be B. Common difference is D, right? A plus D, A plus D, 2D, so common difference is D, right? So each and every term you can now find out. Suppose T2, that is A plus D. Now how do we find out D? See, this is the first term, this is the last term, that is n plus 2th term. So what we can write is A plus n plus 2 minus 1 D is equal to B. So by solving this equation we can find out the value of D. So D will be B minus A upon n plus 1, right? This is first term, this is first term, this is last term. There are n arithmetic means between A and B, so total number of terms will be n plus 1 plus 1. Total number of terms will be n plus 2, and this is n plus 2th term, right? So A plus n plus 2 minus 1 D should be B. Here A is the first term and we had know the formula A plus n minus 1 D for nth term. right? So for n plus 2th term, here n will be replaced by n plus 2. Okay, so a plus n plus 2 minus 1 d is equal to b. So d can be calculated as b minus a upon n plus 1, right? So second term will be a plus d, put the value of d as over here. Similarly, third term will be a plus 2d, put this value as d. And similarly, you can find out the arithmetic means between a and b. Okay. Now we see the properties of an arithmetic progression. If a1, a2, a3 are in AP whose common difference is d, then for fixed non-zero number where k belongs to R, a1 plus minus k, a2 plus minus k, all of them will also be in AP where the common difference is d. I can take just one example over here. Suppose I have the number of terms in AP. Suppose I take a very simple example, 2, 4, 6, 8, 10 till 20, right? Now all these terms are in arithmetic progression, right? Now if I add a constant number in each of the term, and that constant number can be maybe plus 3, right? So I add 3 on to all these numbers, so it's 5, 7, 9, 11, 13 and 23, right? So this is the original arithmetic progression, and it is the original that is the arithmetic progression obtained by adding 3 to each term. Now still it will be an AP, right? And the common difference will still be same. Here the common difference was 2. Still over here also the common difference is 2, right? So that is the property of arithmetic progression. If you add or subtract, not only add, if you add or subtract a constant number to each term of the arithmetic progression, then the resultant is also an arithmetic progression, right? If you deduct, suppose this is your original AP, if you deduct 2 from each term or maybe 3 from each term, you'll be getting this AP. So still the difference between the two is same, and still you are getting an arithmetic progression. Okay, so that's very simple. Similarly, if we have an arithmetic progression, suppose I take this example once again, and if we multiply each term with a common number, suppose I take this and multiply each term by 2, right? So it's 4, 8, 12, 16, 20 and 40, right? Still it will be an arithmetic progression, but what will happen? The common difference will be changed, right? I multiplied each term by 2. Now the common difference, earlier it was 2. Now the common difference will be 4, right? So if original AP is A1, A2, A3, and if you multiply each term by k, then the common difference will be k times d. Okay, similarly the same thing here for division. In the case of division also, if this is an original AP, then if you divide each term by say 2, what you'll be getting? 2, 4, 6, 8, 10 and 20, right? So finally you are also getting AP, and the common difference between the two terms will be what? The difference over here divided by k, right? That is 2 over here. Okay, so even if A1, A2, A3 are in AP, then if you divide each term by a constant number k, then the common difference will be d by k. The common difference initially was d, now the common difference will be d by k, right? So these are the basic properties of arithmetic progression. Now friends, let's discuss geometric progression. A progression is called a GP, that is geometric progression, if the ratio of its each term to its previous term is always a constant. This constant ratio is called common ratio, and it is generally denoted by R. I take an example over here. Suppose I have a series 2, 4, 8, 16, 32, 64, something like that. Now you just see this term divided by this term. 4 divided by 2, you'll be getting 4. 8 divided by 4, you'll be getting 2. 16 divided by 8, you'll be getting 2. 32 divided by 16, 2. Right? So the every next term is twice of the previous term. Right? So common ratio of all the and the entire sequence is same, right? That means this divided by this, the next term divided by the previous term is same, right? So this is a GP, that is geometric progression, and the common ratio over here is 2. This is first term, that means A is the first term, that is 2, and common ratio is R, that is also 2. Okay. So how do we represent a GP? Suppose the first term is A, then the second term will be AR, then the third term will be AR square, AR cube, and last term is AR n minus 1. That is nth term of a GP is AR n minus 1. In the second term there is 1R, in the third term there are 2R, fourth term 3R. So in nth term there will be n minus 1 R. Okay, so this is the formula for nth term of the GP, right? Suppose for this particular sequence, if you have to find out the 50th term, right? So how do we do that? T15 is equal to A, that is 2 into common ratio 2, n minus 1, that is 15 minus 1, 14. So that is 2 raised to 15. So that will be the 15th term of this particular GP. Okay. Now let's see sum of first n terms of a GP. Just now we have found out the formula for nth term of the GP. Now let's see how do we find out the sum of first n terms of a GP. So it is actually sum is A plus AR plus AR square till AR n minus 1. So there are two cases. This ratio can be this R, or the ratio can be more than 1 or it can be less than 1. Now more than 1 means 2, 4, 8, 16, this sort of sequence, and less than 1, that means 32, 16, 8, 4, 2, 1, half, and so on, right? So there are two formula, if R is greater than 1 or if R is less than 1, right? So in this case, the first formula, if R is less than 1, sum of n terms of GP will be A 1 minus R raised to n upon 1 minus R. Here R is less than 1. Okay. Similarly, if R is greater than 1, then instead of 1 minus R and 1 minus R is to n, it will be R is to n minus 1 and R minus 1. Okay. So depending upon the case, if R is greater than 1 or less than 1, we use the formula. Okay. Now let's see how do we find out the sum of infinite terms of a GP. Infinite terms means never ending. There is no nth term. As we are given over here, this is the nth term, but in case of infinite terms, there are infinite terms. That means there is no nth term, no fixed number of terms like 5, 6, 10, 20, nothing like that. The terms will be infinite. Okay, so we can find out the sum of infinite terms when the common ratio is less than 1, right? In the other case, when the common ratio is greater than, we cannot find out the sum of infinite terms because it will be a very, very, very big number, right? So that is mathematically not possible to find out the sum. Suppose this is a sequence over here, 2, 4, 8, 16. The coming terms will be 32, 64, 128 and so on, right? So you'll be getting bigger and bigger and bigger terms. So it's really difficult or mathematically not possible to find out the sum, right, of infinite terms, I'm telling. Okay, till nth term, no problem, but for infinite terms, you cannot find out the sum if common ratio is greater than 1. But in this case, if the common ratio is less than 1, then what happens? See, after 1 by 2 you'll be getting 1 by 4, 1 by 8, 1 by 16, and gradually the terms will be smaller and smaller and smaller. Okay, as good as a 0. We can consider them to near to 0, right? Because 1 by 256, 1 by like 1020, these are hardly, they carry hardly any value, right? So in this case, it is possible, mathematically possible, to find out the sum. Okay, so we can find out the sum of infinite terms of a GP only when common ratio is less than 1. This is the necessary condition. Okay, now how do we do that? We have already explained this formula. That's S of sum of nth term is a1 minus r raised to n upon 1 minus r, right? So sum of nth term is a1 minus r raised to n upon 1 minus r, right? Now this is sum of nth term. If I want sum till infinity, then that means S infinity, here n tends to infinity, right? N tends to infinity. A1 minus r raised to n upon 1 minus r. Now since r is less than 1 and r is less than 1, suppose r is maybe any quantity that is less than 1. So a number that is less than 1, if it is raised to nth power, it will be as good as 0, right? So what we can say is a1 minus 0 upon 1 minus r, or that is a upon 1 minus r. For example, suppose 1 by 2 raised to say 500. So it will be a very small term as good as 0, right? So r raised to n will be 0. So sum till infinity will be a upon 1 minus r, and that's a really important formula. Okay, and the necessary condition over here is r should be less than 1. Okay. Now if what is geometric mean, let's discuss. If a, g, b are in GP, then G is called GM between A and B. I have suppose 2, 4, 8, 16, 32 and so on, right? So in that case, if we take these three terms, then 4 is the geometric mean between 2 and 8. Now what is 4? That is square root of 2 into 8. Okay. What is 8? That is square root of 4 into 16, right? So geometric mean is what? A into B and square root. Similarly, if 8, 16, 32 are there, the three consecutive terms of the GP, then geometric mean of between 8 and 32 will be 16. That means 8 into 32, if you take the square root, you'll be getting 16. Okay, so 16 is the geometric mean between 8 and 32, 4 is the geometric mean between 2 and 8, 8 is geometric mean between 4 and 16, and so on, right? Now next is harmonic progression. Now what is harmonic progression? A progression is called a harmonic progression if the reciprocals of its terms are in AP. Now what is the standard form? You can assume it to be 1 upon A, 1 upon A plus D, 1 upon A plus 2D and so on, right? Suppose 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5. This is an example of harmonic progression because 1, 2, 3, 4, 5, all these terms are in AP, right? So reciprocal of this progression is in AP, arithmetic progression. Okay, so the sequence given over here, 1 by 1, 1 by 3, 1 by 5, 1 by 7, 1 by 9 is HP, that is harmonic progression, because 1, 3, 5, 7, 9 are in AP, right? So what is the general term of an arithmetic progression? That is A plus n minus 1 D. That is the general term of an AP. So what will be the general term of an HP? That is reciprocal of this, right? So that's pretty simple. We cannot find out the sum. There is no specific formula to find out the sum of all the terms of an HP, right? So no need to bother about it. You just have to understand that it is just the terms of an AP. If they are, if we reciprocal them, we'll be getting the terms of HP. That is harmonic progression. Now, harmonic mean between A and B is given by 2AB upon A plus B. Suppose we have the sequence 1, 1 by 3, 1 by 5, 1 by 7, 1 by 9 and so on. This is suppose A and this is suppose B. So harmonic mean between A and B we can calculate, that is 2 into 1 into 1 by 5 upon 1 plus 1 by 5. So that is 2 by 5 upon 6 by 5, that is 2 by 6, that is 1 by 3. Okay, so harmonic mean between A and B is what? 1 by 3. So general formula for that is harmonic mean between two terms is 2ab upon a plus b, right? Similarly, harmonic mean between 1 upon 3 and 1 upon 7 will be 1 upon 5. So 2 into 1 upon 3 into 1 upon 7 upon 1 by 3 plus 1 by 7, you'll be getting 1 by 5, right? So that is actually harmonic mean. We understood arithmetic mean, that is a plus b by 2 between a and b. If we talk geometric mean root ab, and harmonic mean 2ab upon a plus b, right? Now there exists a special relationship among AM, GM and HM, right? Now what is that? AM is a plus b by 2, HM is 2ab upon a plus b, right? That is arithmetic mean into harmonic mean is equal to, what is AB? That is GM square, right? That is square of geometric mean, right? So what is the relationship among AM, HM and GM? That is AM into HM is equal to GM square. So that's actually an important relationship. Okay. Apart from that, we have a very important property, that is between two numbers. Suppose we have A and B, positive numbers I'm talking about. So between A and B, AM is greater than equal to GM is greater than equal to HM, right? If A and B are unequal numbers, then AM will be greater than GM will be greater than HM. If they are equal, then all of them will also be equal, right? So that's really very important. Good number of questions based on this property are asked in various competitive exams. You must be knowing this. A and B are positive numbers, unequal numbers. In that case, AM is greater than GM is greater than HM, right? Suppose we have the two numbers 2 and say 8, right? So arithmetic mean will be 8 plus 2, 10 by 2, 5. Geometric mean will be 8 into 2, that is 16, square root will be 4. HM will be 2 into 2 into 8 upon 10, that is 8 2 is 16, 2 is 32 by 10, that is 3.2. So AM is greater than GM is greater than HM. Okay, and if the numbers are equal, all of them will be same. So that's very, very important. Okay. Now here I have examples of special series. Sum of first n natural numbers, that is 1 plus 2 plus 3 till n, is given by n plus 1 by 2. Direct formula you should learn. 1 square plus 2 square, that is sum of squares of first n natural numbers, is given by n plus 1, 2n plus 1 by 6. Sum of cubes of first n natural numbers is 1 cube plus 2 cube till n cube. So that is n plus 1 by 2 square. Okay, now suppose you have to find out the sum of first n odd natural numbers, right? N odd natural numbers. So that will be 1, 3, 5, 7, 9, and the nth term will be 2n minus 1, right? So you can directly use the formula, that is sum of an AP is n by 2 a plus l, right? So here Sn n by 2, first term is 1, last term is 2n minus 1. So n by 2 into 2n, that is n square. So sum of first n odd natural numbers will be n square. That is, if you have to find out the sum of first 10 odd natural numbers, 10 odd numbers, I'm talking about natural numbers over here. So sum of first 10 odd numbers, it will be 100. Sum of first 9 odd numbers, it will be 81. Right? So that's pretty simple. Similarly, you can find out the sum of first n even numbers, right? Suppose it is 2, 4, 6, 8. Then the nth term will be 2n. So sum of nth term will be n by 2, a plus l, that is 2 plus last term is 2n. So it's n by 2, n plus 1 into 2. So that is n plus 1. So sum of first n even numbers is given by n plus 1. If you have to find out sum of first 10 even numbers, it will be 10 into 11, 110. Okay, so that's pretty simple. So friends, in this session we have discussed the formula and the basic concepts of all the three progressions, that is AP, GP and HP. In the next session we'll be discussing some more properties and we'll be solving the problems based on AP, GP and HP. So do revise this session before you come for the next session. Bye bye.